Hey, this is Jesse with Create This. Today is July 27th, 2025. It has been a little while since my last video, and a lot has changed in the world of local LLMs. In the previous videos, I mostly focused on DeepSeek v3-0324. We recently, in the last week or two, got kimi-k2 and also Qwen3-Coder. And both of these are excellent models, to the point where I would say that DeepSeek v3-0324 is probably obsolete. But I'll let you be the judge of that in this video. So throughout this video, I will have section headers down below the video that you can use to skip to different sections of the video. So I tend to drone on. There's a lot of material to cover here. I don't organize my thoughts super strictly, so I'll talk a lot. And when I do, feel free to fast forward or to skip to another section that interests you more. I do the same thing when I refer back to these videos because they're a bit of a documentary for myself as well. A little bit of background on my machine if you didn't watch the previous 3 videos at this point, I guess. So I'm running a dual EPYC 9355 machine, so 2 9355 CPUs. The 9355s are different from the 9355Ps because the 9355P is a single CPU, single socket CPU, so it's a little cheaper. And the reason why I run 2 of them is for system RAM bandwidth. Bandwidth is king when you're running LLMs. You want as much throughput as you can possibly manage. I have 24 channels on this motherboard, so 24 RDIMMs. And I'm running MTS 5600 RDIMMs, and they're all 32 gigabytes. So I've got a total of 768 gigabytes of system RAM. I had one of those DIMMs go bad. I've had this machine for several months now, and one of them recently had to be RMA'd. I don't really know why it died. It might have been a lightning strike. It might have been manufacturer's defect. I don't know, but I got paranoid enough about it that I bought a UPS for the machine. So I now have like an Eaton 9PX UPS that protects it. So that's cool. And that also gives me the ability to show you a visual of the wattage that the machine is drawing as I'm running it if I want to. Before I had to just kind of, you had to trust me, bro, because I had like a meter on there. In the previous videos, when I would run DeepSeek v3-0324, I would run them like this. So I would do NGPU layers 62 to offload to the GPU. And then I would do OT, so this is with llama.cpp. I would do OT ffn.star exps equals CPU. When I switched over to my Blackwell 6000 Pro GPU, I now have 96 gigabytes of VRAM available. And with these commands, these command line arguments to llama.cpp, I would only get about 35 gigabytes of VRAM being used out of the 96. So that's not super, I wasn't using the GPU to its fullest, right? So I was talking to the ikllama.cpp people. One of those people just told me how to use that OT command line option a little bit more effectively. So now I do the same NGPU layers 62, but for the OT option I pass BLK, I assume that stands for block, and I give it a list of block numbers, .ffn.star equals CUDA 0. So I only have one GPU in my machine, right? So there's not a CUDA 1 or anything, but CUDA 0 is my GPU. And this basically shoves all of these layers onto the GPU. So that's great because what it does is it speeds up generation tokens per second, and it also speeds up prompt processing tokens per second. It speeds up prompt processing dramatically, and it speeds up generation just slightly, okay? So a way to visualize that is perhaps a benchmark. I don't love the benchmark that llama.cpp comes with. ikllama's benchmark is a little better, but it hasn't been ported back to llama.cpp yet. So I use this llama batched bench, and you can read through all of these options, but basically when I run it, it should only be doing like one layer or one iteration, I believe. And I don't love the tokens per second. I don't think that this is very accurate, but it does give you a gauge of like whether a given number of command line options are more efficient or less efficient, right? So that you don't have to like try it for like 100K context to see if you like it or not, right? So I like running this to figure those things out. So SPP tokens per second is prompt processing tokens per second. So I'm running Unsloth's UD, Q4, KXL quants for all of these models. And with that quant, I'm getting 189 tokens per second prompt processing from V30324, okay? Generation tokens per second is going to be less than 75. That's not accurate. It's more like 21, 22, something like that, right? And that's starting out. As context gets higher, as we've created a longer conversation, essentially, generation tokens per second goes down. So this is with 163K context length, okay? So that's important because the more context length you have available to the model, the slower your initial generation tokens per second will be. And also, I think the slower your prompt processing tokens per second will be. I could be wrong about that last part, but I think that's right. 163K, that's the most that this model, DeepSeek V30324, can handle. So I usually run the most that it can handle, except in the case of Qwen3-Coder, because Qwen3-Coder is really weird. It's cool. Like the most that model can handle natively is 262K, okay? When I do that, I get pretty abysmal tokens per second. I don't like it. I mean, it's not bad, but it's just not quite as fast as I would like. And I don't really need that much context, honestly, for like most of the stuff that I do. You don't have to, if you don't need that kind of context length, you don't have to run it all the time. You don't have to take that, you don't have to incur that penalty, right? So what I do is I par that down to like 131K. And then what that allows me to do is it allows me to crank up the number of layers that go to the GPU. So you can kind of see the difference here. Like I'm getting 14 layers to the GPU, whereas with the full context, the full native context, I can only get 6, right? And so that has a pretty significant impact on performance. If we swap over to kimi-k2, just so you can kind of see, I can only get 8 layers to the GPU with 131K context. And that's because kimi-k2 is a larger model and just the way it's organized. But again, these are all Q4 KXL. I did run Q8 with Qwen3-Coder because it's a smaller model than both DeepSeek V3 and kimi-k2. With Q8, I can only get 1 layer offloaded to the GPU, and it runs pretty slow. So again, I don't really trust this. I seem to remember it was getting about 13 tokens per second generation. I don't remember what the prompt processing was, though. It's probably pretty slow. It's probably right around 14. So Q8, even though Q8 is a smaller model than Q4 in V3 and also in kimi-k2, even though it's a smaller file size, it infers much more slowly because it's Q8. So I run Q4. And that's actually kind of nice because Q4 in Qwen3-Coder runs quite fast. I really enjoy working with this model. Let's look at file sizes first because that's relevant, right? So let's do DeepSeek V3 0324, and we'll do the Q4. It's UD Q4. So this model on disk is 358 gigabytes, which is not terrible. That's actually kind of small. Kimi-k2 instruct in the same quant size is 547 gigabytes on disk. Because remember, kimi-k2 is a 1 trillion parameter model. DeepSeek is a 670 71, I believe, 71 billion parameter model. So it's a smaller model, right? And then let's look at Qwen3-Coder. So you can see Qwen3-Coder is a 480 billion parameter model. So it's smaller, it has fewer parameters than DeepSeek v3 0324 and, you know, less than half of kimi-k2, right? Kimi-k2 is huge. And that translates to disk size, right? But if we look at the Q8 here, so Q8 is about, you know, it's a little bit less gigabytes on disk than kimi-k2, but it actually performs slower just because it's Q8. So I don't really know exactly how that works. I think it has to do with PCIe bandwidth and the amount of traffic getting thrown around between the system RAM and the VRAM. But it is what it is. That's just how it works. So we're going to ignore Q8 for now. If you want to run that, go for it. But I like Q4 because it's more performant on my system. And I don't really see, for the work that I do, I don't really see any quality loss. If I was noticing that Q4 was dumbing these things down like severely, I wouldn't run it. But Q4 is fine for what I do. All right, so for our control, so to speak, let's start up DeepSeek v3 0324. Even though it's probably obsolete at this point, let's just start it up and run it, and you can kind of see how that works, and then we'll move on to the other models. By the way, the entire time in the video, you can just look up here. I will speed things up in the video so that you don't get bored out of your mind as you're watching. But even when I speed up time, you can still take a look at this clock up here in the upper right to get an idea of how much time has elapsed. So we're starting this at 8:55 p.m. Okay, we're all booted up here. Okay, so I like to just start off with a test. Then in the output, we can kind of see that it's running. All right, and let's just take a look over at NVTop. So we can see that I've got 96 gigabytes available of VRAM, and it's using 93. GPU usage is a bit higher than it was before too. And if we run top here, we can see that we're using about 303 gigabytes of system RAM. So that's good. And for that initial prompt, we're getting roughly like 30 tokens per second prompt processing speed and 24 tokens per second generation. So there are several prompts here because I'm using Open WebUI, and after I make my query, it will generate one for the title as it files the conversation in the user interface, and then it also does one for tokens for searchability. So that's why there's 3 of them. So the next thing that I like to do is a poem. So write a poem about summer. You can kind of get a feel for how fast that's going in real time. It's pretty speedy. Good stuff. So you generally tend to see more tokens per second prompt processing based on how large the amount of data is that it has to filter through. For smaller prompts, the tokens per second can be lower, so that's fine. You'll still see pretty in the hundreds for large batches. And as time goes on, as your context length gets deeper, so we're like 204 is our context length, or 313, something like that. As you get further into that and closer to the 163K that you have available, your tokens per second will go down, right? Now, let's do something a little bit more complicated. One of the things that I've started doing is I've started using LLMs to audit code. So here I've got the llama.cpp project, and what I've done is I've set up some scripts, and we can actually take a look at these. So put these in another tab here. Okay, so this is a public repository on my GitHub. The GitHub is create this, and the repository is 0727 2025 Agentic Audit video. And so you can grab these scripts there. Audit file, audit init, and audit next, and then also a prompt. And so the README will talk a little bit about why that is, but basically the gist is when you're auditing large code bases with LLMs, you have limited context, right? And so they'll be reading files one at a time, and you need some way to like save your progress so that if one of those files is really, really huge and it blows the context length, or it gets really close to blowing the context length, that you can then move on to the next file and save your work for the previous file, right? So one of the ways that I devised to do that is just using like a flat file system as a database. So I've got a audit issues.csv file, and that's where the output goes. So that's the work product. And then I've got audit files done. These are the files that we've already looked at. I've got audit files to do. These are the files that we haven't looked at yet. I've got audit ignore. These are regex patterns that specify files that we don't want to look at. And then I've got audit files, which is the complete list of files, ones that we have looked at and haven't looked at yet, right? Like the whole list. So what these tools do, these bash scripts, is they give the LLM sort of an API to interact with these files, because I don't want to have to put all of that into a prompt, right? So with agentic AIs, they can call bash commands. So I just made some bash scripts that make it easy for the AI to keep track of its work and move on to the next item, right? So in my prompt, I say things like, hey, the first thing you're going to do is you're going to run the audit init script, and this will create those dot files if they don't already exist. The next thing that you're going to do is you're going to run audit next, and that'll give you the next file to work on. It'll also give you like a percentage that you're done with the audit, because audit init created the full list of files that you're going to look at, right? So audit next then knows the percentage based on those other dot files. So it's just like a little in-file system database. It's lame, but it does the job. And then what you end up with is a CSV that sort of has this format. So we'll talk about that more later. But basically, there's my prompt. And so I'm going to speed this up so that it won't bore you, obviously. But let's shove this into open hands, and we'll let DeepSeek v3 have a go at auditing the llama.cpp project. And all we're looking for in this prompt, like the prompt determines like what we're looking for in the audit, right? And so all we're looking for is data exfiltration, basically. So network calls, any of this stuff, right? Third-party API SDKs that might make network calls, unencrypted transmissions, suspicious DNS entries, or uploads to logging libraries and things like that, right? So your audit is only going to be as good as your prompt, and there may be things that I haven't thought of that should be in this prompt that aren't, but this was just like sort of something that I came up with to check these inference engines to see if they're like basically like shipping off your prompts to like somewhere else, right? As you talk to your AI, because these are supposed to be local models. You're supposed to have privacy and security. That's the whole point. So that would really suck if they were like shipping things off, right? And so you can do the same thing with Open Hands itself, right? I think I've maybe run one audit on Open Hands. I'm not sure. I definitely ran one on K-transformers. I haven't finished an audit on llama.cpp yet, but this is just an exercise at this point, right? We're just running this for to see how the different models compare in an agentic task. So let's go ahead and get started. We'll run this once with DeepSeek v3. There are a lot of files in llama.cpp, so we'll maybe go like 2% into it. And I think that'll probably take about an hour for it to run through, but we'll see. Maybe it's faster than that. And then I'll stop it, and this will all, through the magic of video editing, pass nearly instantly for you all. And then we'll talk about how well it did, things that I like about the output, things that I don't, stuff like that. And then we'll move on to the next model, okay? Let's go. Okay, a bit of a time jump. It is 9:52 p.m. I ran a couple of these, but they failed because I was running an MCP server, and it was offering a read file tool. I'm just checking the MCP tools that are available, and it's not in there anymore. Normally, it'll use like cat or something to read a file, and I had a different tool set in there from a previous project. And anyway, the MCP tool was using absolute paths, and the rest of these bash scripts for modifying the state of the audit are using relative paths, and it was confusing the hell out of it. So let's try this again. We'll start over. So start time 9:53 p.m. So 26 tokens per second generation, 36 prompt processing at the very beginning of the conversation. We're using 95% of my 96 gigabytes of VRAM, so 93 gigabytes are used. We're using roughly 61% of the GPU. Top shows we're using about 303 gigabytes of system RAM. The UPS says we're pulling about between 590 and 870 watts from the wall. And the IPMI interface says that our two CPUs are 54C and 45C, and the LAN temp, which is usually the hottest temp in the system, is 78C. So off to a good start. I'll shut up and let it run. Just after reading that first file, we're already up to like 15K context. So OpenHands has a pretty hefty system prompt. I think a lot of it comes from that, but also you can burn context pretty quickly when you're reading whole files. So this is an interesting finding. Tests.sh script contains one network-related operation worth noting. Line 24 downloads a model file using huggingface.sh script from Github. This is an expected test dependency download, not a data leakage risk. Since this is a test script performing expected downloads, not transmitting sensitive data, we can mark it as audited with no security issues. Let's proceed. So it chooses not to mark this one because it doesn't think that it's a risk. So very interesting. So I think this sort of highlights the risk of trusting LLMs to do anything without supervision. They sort of get lazy. And so in our prompt, it says, you must read the entire file, analyze line by line, right? And so you'll notice that it has gotten lazy and it has stopped doing that. It started off doing that. But then the last few files here, it's running a grep against them. And it's like, grep is a tool that can analyze multiple files at the same time, right? Like we could just run a grep across the entire code base for like every file and just see the results and have it look at those. But instead it's running this grep pattern for each individual file. It's kind of silly. And then it's not looking at the file itself. Sometimes it does. Like in this one, it's like reading like the first 20 20 lines of this negative.txt, but it's not consistently reading the file like it's supposed to. It's interesting. Okay, so we've hit 2%, so let's just call it right there. So that was about 30 minutes. As soon as this takes open hands a little bit to close down the AI. Okay, we got about 34K of context because it wasn't reading the files. It was just running greps and stuff. And at 34K context, we've degenerated down to like 19.7 tokens per second generation speed. Let's see how many files it went through. Audit files done is going to be 25. So it hit 25 files, but I mean, mostly it just ran greps, which is just silly because you can just do a recursive grep. I'm really annoyed with that. And that's probably as much a prompting issue as anything else, right? Like, I could probably tweak that prompt and get it to be a little bit more accurate and get it to stop doing that, but it just shows the importance of watching these things as they do their work. Let's see about the output. This one found no issues, no data exfiltration whatsoever. Probably not a great result. I don't know. I would call that poor. So DeepSeek v3 0324, I would call that a poor result. One thing that I did like about it is it gives me a little summary for each thing that it's doing. And so combined with the terminal output, that's a pretty easy way for me to like sort of see what's going on and what it's thinking. I like that. Not all of the models do that, as you'll see in a second. Let's do kimi-k2 next, okay? I run these commands to sort of clear up the memory cache on the system. Let that boot up. Switch open hands over to a new they call them runtimes, but it's basically a new session. I'm not going to run it just yet because the LLM is not ready. And I'm going to clear all of the audit files. So we have to remember that nothing was written to the CSV, okay? We'll just remember that as the output or the results. Okay, and we'll just wait for kimi-k2 to start up. Okay, kimi-k2 is up, and away we go. 950 watts, somewhere between 620 and 950. Same temps. Looks like our initial prompt processing is 180 tokens per second and 23 tokens per second generation. Pretty good speeds, not bad at all. GPU's at 45C. Using 91% of the memory, 89 gigabytes, 63% of the GPU. We've got 491 gigabytes resident in memory, by far the most out of any of the models. We'll see how it does. It is 10:34 p.m. It probably started at like 10:32 or 10:33. So this is interesting. It tried to read batchedbench.cpp. And I think what happened here is I think OpenHands truncated the file because it's got this X. I think that's what that means. And so then it noticed that it was truncated, and so it starts running greps instead. So I think one way that I could maybe make this a more efficient process is if when I did the audit next, instead of returning just the name of the file, I returned the name of the file and the contents of the file. And then that way it wouldn't have an option to not read the file. It would be forced to read it. And also, it couldn't get truncated by OpenHands. So fair enough. There are ways to work around things like this. Okay, that's at about 2%. We'll call it for kimi-k2. It's 11:06 p.m., 11:07. I don't actually remember when we started, but I bet that was about a half an hour. Final speed at 51K context is about 20 tokens per second generation. Not bad at all. Let's look at the files that it generated. I think it did a much better job than DeepSeek V30324. So it found 6 potential issues. Looks like they're all Hugging Face server transmission issues, which, you know, is fair. It is what it is. Let's see how many files it took a look at. Twenty-six files in that time, in that context. So that was a pretty good run. Oddly enough, the first time that I ran kimi-k2, before I even started the video, it got about 30K context in and just completely decided to stop following instructions. It just started using grep for everything, grep and sed, and stopped using the tools completely. So this is a much better result. I like kimi-k2 when it works. I like it a lot. It does occasionally go off the rails though, so you gotta kind of keep an eye on it. So let's spin up Qwen3-Coder. Again, clearing out the caches. This should be the fastest one of all 3 of them. While that's loading up, I'll just prepare my session over here. 44E. I like to kill the runtimes that are not currently running. Seems to save trouble. Okay, OpenHands is ready to go, but the model is not loaded yet. Oh, I can also clean up the files. Clean file history. Okay, and again, keep in mind we're running this with half context to get speed out of it. We've got 92 gigabytes of VRAM loaded, 94% used. We've got 208 gigabytes of system RAM used. Let's kick it off. Only using about 760 watts. Same temperature as before. Okay, now it's up to 920. Yeah, fair enough. So one thing that I notice about Qwen3-Coder immediately is that, and it did this last time when I tested it too, it doesn't like to talk. So it's doing things, but it's not talking about what it's doing. It's just doing the things. So I don't know whether that's a good thing or not. I kind of would prefer that it would like give sort of a running commentary of what it's doing, but you know, it saves context, I guess. It's not terrible. I don't hate it. Like, why did it just read that file twice, you know? Like, I don't know. And so it'll do a thought tag occasionally, and it'll actually talk, but it just doesn't do it all the time. So looking back, let's see. So it's like 11:17, so we probably started this at like 11:15, something like that. And looking back at the history in Llama CPP, ooh, that initial batch, wow, that's some speed right there. 416 tokens per second prompt processing. That's wicked, wicked fast. Only 23 tokens per second generation, not, you know, not anything to write home about, but not bad either. But man, that 333, that is blazing fast. That's amazing. So that's I would argue that the speed is one of the greatest benefits of this model, because if all else is the same, if it performs the same as the other two models in exactly the same context, it's way faster, and that's worth something. So, but you'll notice prompt or generation tokens per second is going down fairly rapidly, right? Like we're at 20K and we're already down to 20 tokens per second, and that's something that I've noticed with this model as well. If we scroll back up, we'll notice that with kimi-k2, we stayed at 20 tokens per second even at 51K context, right? So very, very little speed drop for, at context. Whereas I feel like Qwen3-Coder is not the same, but we'll see once we get into some deeper context here. All right, we're at 2%. We'll call it. I didn't see any weird shenanigans going on with this one. It looked like it was just doing its job. Let's see how it did. So we got up to 55K context. At the end of the context, we were down to 13.92 tokens per second, right around 14. So that's significantly slower at 50K than kimi-k2 was. So it's kind of interesting. By the way, I don't know if it's Kimi or if it's Kimi. I looked it up. Google seems to give me different results on the day, depending on the day that I look it up. So if I'm butchering that, I apologize. Anyway, yeah, let's look at the files. Let's see how it did. It's getting kind of late. I'm getting tired. So we've got audit issues. It found some stuff. That's cool. How many? 7. Neat. Let's look at them. Hugging face. Requirements.txt. Yeah, I feel like that's pretty solidly a false positive. External PyTorch package index URL and requirements file. Extra index URL. Tools, MTDM, requirements. Yeah, so I'm not an expert on requirements.txt, but my understanding is that it's basically like the same thing as a package lock in Node, or a gem file in Ruby or something like that. So it just has like packages that you're going to load up every time you run the software. So I don't think specifying an alternative index qualifies as a data leak. I feel like that's a false positive. Hugging face. Hugging face. Oh no, it's another suspected data leak. Interesting. Let's look at this one. I don't remember seeing that in the other one either. This is load model. Checkpoint file type, load model. Pretty sure it's line 66. Yeah. There we go. Loading model files may transmit sensitive information. There may or may not be something to that. I don't know. I'm like, nothing's jumping out at me right there, but that doesn't mean that it's not a thing. I would have to look into that a little bit more. Hugging face, and then another suspected data leak, line 40. I'm admittedly looking at these harder than I was the kimi-k2 ones, because the kimi-k2 ones just said hugging face, and I was like, maybe it's an issue, maybe it isn't. I don't know. I'd have to look at it. But they all said the same thing, and these say something different every other one. So yeah, I don't know is the answer there. I would have to look at that. I think probably most of these are like false positives in both cases, in the kimi-k2 and in the Qwen3-Coder. But it's interesting to compile these lists and then look through them a little deeper to see if there's an issue or not. Overall, I think that was pretty successful. Again, I don't like that it slows down so dramatically towards the end of the context. I also don't like that it doesn't talk as much. I'm not sure why it does that. It's possible that it's something to do with Llama CPP that needs to be updated, or it's some incompatibility with Llama CPP and OpenHands. Like, I know that OpenHands doesn't handle reasoning code or reasoning content very well when you've got the Jinja specified, the Jinja command line argument. So I do have that specified at the moment, and it's possible that some of this stuff is coming across as reasoning content, and so it's being thrown out. I don't know. I'm not really sure, but I don't really hate it. Like, it's fast enough that it's fine most of the time, but I do prefer to see a little bit of data there. I've been using kimi-k2 for, like, I think I used it for a couple of weeks, and I've been using Qwen3-Coder for maybe a week. I like them both. I like Qwen3-Coder a lot because it's a little faster. So like, if it can get the job done and it can do it faster, then I'm all about it, you know? I don't like that it slows down, but I still feel like it's pretty fast, even though it slows down a little bit at the end there. For some reason, like, in my mind, I feel like it's faster. Maybe it's not, though. Maybe I should reevaluate that. So, and sometimes I feel like kimi-k2 goes off the rails and does stuff on its own that it shouldn't be doing, that I didn't ask it to do. But as you can see, DeepSeek v3-0324 just did the same thing. And it is not my general impression that DeepSeek v3-0324 does that on a regular basis. So maybe that's just a random thing that tends to happen with models in general, and I just need to be cognizant of that. I don't know. I was a little surprised by that result, because it usually is pretty good at just following instructions and doing what I ask. So anyway, hope you found this video interesting or useful. If you did, please like and subscribe. And if you have any questions, or if you'd like me to look at anything else, feel free to leave a comment down below. As always, thanks for watching.